So let's take another example where we have hypothesized a different value for beta j. So this is an example for that has information on crime rates and enrollment on college campuses. And if we wanted to predict crime near college campuses, we can set up a model which is very, a simple linear regression here, which says that the enrollment in college can affect the crime rates. Okay, so this is your x, this is your x, and this is your y. Okay, and we might have good reason to believe that the elasticity which is captured by beta 1 is positive, which is to say that when enrollment is high in college campuses, crime in that area will also be high because maybe there are more students walking around and there's more opportunity for people to mug people, mug students, etc. Okay, so we might be convinced that maybe we want to test a one-sided alternative. We think that this is greater than 1, but we can be agnostic. Okay, so if we were wanting to test whether this elasticity is 1 or not, right? So if this elasticity is unitary or not, then we can set up a hypothesis in this way. So we can say our null hypothesis is beta 1 is equal to 1, and our alternative is beta 1 is greater than 1. So here we are actually doing a one-sided test for beta j equals 1, right? Which is different than 0. So if we use the campus data and estimate such a regression from the Woolrich package, we would find that beta 1 is 1.27, right? So the way to interpret this would be to say that a 1% increase in enrollment is estimated to increase crime by 1.27%. Okay, so it's a little more than a 1-for-1 increase, right? So a little over 1%. So if enrollment is going up by 1%, then that's increasing crime by 1.27%. Now, we might want to ask the question, is this estimate statistically greater than 1, right? Is this value really greater than 1, or is it just, or not? Okay, so that's why we would want to use a different null hypothesis. And so here it's really easy. The way we set up our t-statistic, just like we did before, we would do it in the same way. We would say, what is our estimate? This is our beta 1 hat, right? So remember, our t-statistic is the estimate relative to the value that we hypothesized, right? Which is 1, divided by the standard error. So if you look at the standard error that your software throws, that is 0.110, right? So you can calculate what this value is, and this is 2.45. Okay, so once we know the t-statistic, we can go to the tables and we can see what our degrees of freedom are and at what level, what significance level do we want to conduct the test, okay? And remember, this is a one-sided test. Because our alternative says that beta j is greater than 1. Okay, so the 1% value is 2.36. Okay, so at 1%, the value is 2.36. I should write this on the right-hand side. So what we're doing is, this is your critical value, and the t-statistic is 2.45. Okay, and because we were testing for, this is a positive one-sided alternative, this is greater, the t-statistic is greater than the critical value, so we reject the null in favor of the alternative, okay, at 1% significance level. Okay, and we'll see later how to set this up in R. We can also sometimes write the null hypothesis. So earlier we said the null hypothesis is beta 1 equals 1. We can also write it out in this way. Right? So you're just taking 1 to the left-hand side. Okay, you can also test this. So you can also do a two-sided hypothesis here. You can test your null against a two-sided alternative, and you can see what you get.